All across the world, humans have created systems for moving fluid from one place to another. Fluids include vapors, liquids, gases, basically anything that flows. Air is a type of fluid. So, what happens when you need to move water from a water treatment plant to your house? Or air in your air conditioning unit from one room to another? Or propane from your propane tank to your grill? Or even a really explosive chemical from one vat to another in a chemical plant? Well, for starters, you need pipes. The pipes act as a vessel to sort of guide your fluid from point A to point B. But the pipes by themselves are pretty useless. If you have a horizontal pipe, your liquid's just gonna sit there and not move anywhere. But you need something to create pressure that's going to move the fluid. There are two main things that create pressure. So number one, you have gravity. If I take my pipe and I tilt it, the gravity is going to create pressure downhill that's going to move the fluid. I could also use a pump, and what a pump does is basically just cram fluid into the pipe that's going to push the fluid in front of it and create a flow. So now we have a pipe with fluid flowing through it, but I don't want the fluid to flow all day. Water is expensive and yo girl cannot afford that. I need something that's going to allow me to let the fluid flow when I want it to flow and stop when I want it to stop. And that is where valves come in. Think of a valve as a gate with three main settings. Number one, it can be completely open, allowing the fluid to flow as fast as the pressure is pushing it. You can have it completely closed, stopping it, nothing is getting through. Or you can have it partially open. We've all had that experience of walking into an unfamiliar bathroom and then opening the sink and just getting absolutely doused with water because the flow is too pressurized and too hard. So what do? You turn it down a little so it's like a nice trickle. Your valve is partially open. Now, let's get into what different kinds of valves you can have. First, think about all the different fluid systems that exist in the world. You have, your water, you could have chemicals, you could have valves that need to be as big as a house, you can have valves that need to be as so tiny you can't even see it with your eye. So you're going to need different valves to do different jobs. That's why it's useful to think of valves sort of like a custom-build D&D or video game character, where you can sort of customize it to pick the characteristics that you want for your fighter. First, you need to ask this question. Is the valve going to open and close on its own because of the conditions that are happening inside the pipe, or are you going to control when to open and close it? We open and close valves with our hands every day. We open and close the sink faucet, we turn the garden hose on and off, we turn the little radiator dial to see how hot we want it to be in our apartment. But it's also possible for machines to open and close these valves. You can have valves that are controlled with magnets. You can have valves that are controlled with electric motors, with air pressure, or even hydraulics. We call these kind of valves actuated valves. Actuator is just a fancy name for something that moves something. So actuated valves have something that controls when the position is open or closed. Now, how would a valve open and close on its own? These valves are using the physics of what's happening in the pipe to open and close. So say you have a pipe that has a lot of pressure and the valve won't open unless the pressure is overcoming some mechanism that's holding it shut. Or maybe there's a valve that allows the fluid to flow in one direction but will sort of get pulled shut if the fluid tries to flow back in the other direction. What's happening is the physics inside of the pipe is causing these valves to move. You're not moving it with your hands or a machine, and these valves are called mechanical valves. Okay, now let's get to part 2 of our valve custom build. How is the valve going to open and close? Well, there are 2 main ways that a valve can move. Number 1, a valve can rotate, and number 2, a valve can move up and down. So in a rotational valve, what's happening is the valve is turning on an axis to open and close. A really common type of rotational valve is a sphere that has a hole in it. So when it's open, it's allowing water to flow through. When it's closed, it turns, and the way that allows it to flow is facing the casing of the valve, and so water can no longer flow through. So when should you choose this build? Think of your rotational valves as your tank characters. They don't have a lot of good control over the partially open position. They're really good at switching from all the way open to all the way closed. They're also really good in situations with really high pressure or really high volume. The other build you can choose is linear valves. Linear valves are called linear valves because the mechanism inside the valve can only move up or down in a line. Linear valves usually include a plunger that sort of moves against the flow to close the position. Anytime you're moving a wheel like lefty-loosey, righty-tighty, like your family garden hose, is a linear valve. Think of your linear valves as your more precision, agility-based builds because these valves have a lot more control over how partially open your valve is. Okay, so now that we know what different builds we can have for our valves, we need to go into what the different combinations will give us. Let's start with the mechanical rotational valve. In this type of valve, some internal condition caused by physics causes a valve to close by rotating on an axis. This build is for when you don't want to use a machine or your hands to open and close the valve, and you don't care very much about how accurate the partially open position is. But what about mechanical linear valves? Here, some internal condition caused by physics is causing a valve to move up or down in a straight line. Use this build when you don't want to use a machine or your hands to open and close the valve, but you need the valve to be partially open a specific amount depending on how much pressure is pushing your fluid. Now let's get to our actuated rotational valves. Here you use your hands or a machine to close or open a valve by rotating on an axis. Use this build when you want to selectively control when the valve is open or closed, but don't care about how partially open or closed the valve is, usually in situations with really fast or really pressurized flow. The last build is the actuated linear valve. Here you use your hands or a machine to move a valve up and down on an axis to open and close it. This build is for when you need to selectively control how open or closed the valve is. These builds are very broad and very general, and there are definitely exceptions, but it's a good framework to have these 4 different builds that you can use to look at your valves. Now let's get more into actuated valves and what's actually actuating them. Number 1, you could use your hand. You use your hand to open and close valves all the time, like your sink or the radiator or a boiler, and it works great. But what about situations where you can't reach the valve? Or what if the flow is really, really heavy and you won't be able to close the valve with your own strength? Or what about valves as big as a house or tinier than you can see with your own eye? Then you need a machine actuated valve. So the most common machine that actuates valves is a solenoid. A solenoid is essentially a metal coil wrapped around a magnet that when electricity is run through it, creates a magnetic field that pushes another magnet that's attached to the valve that can open or close it. You could also have air pressure to actuate your valve, which is great if you need to shut off your valve really, really fast. You could also use an electric motor, which can get really, really accurate, even though it's kind of slow. And also, in situations where an electric motor or air pressure or magnets won't produce enough force to close your valve, you can use hydraulics. So really big chemical plants like oil refineries or water treatment plants have lots and lots of valves that sort of work together to regulate the flow throughout the whole plant. Now, in the past, operators had to sit in a control room with hundreds and hundreds of pressure gauges and dials that they would use to sort of monitor the pressure. And if a pressure gauge needle sort of popped up and got too high, they would press a button that would allow a valve to sort of release the pressure. But now, with computers, we don't have to rely on some really tired dude looking at all of these tiny little dials. We can hook the computer straight up to the pressure gauge and program it so that it can release the valve automatically when the pressure gets too high. This is great for preventing environmental disasters and making plants way safer for the people that work there. So now that we know how to pick our valves and how to control them, let's look at some more specific in-depth examples of each of the different builds that we've created. Let's start with your sink faucet. It contains a ball valve shown with this animation, which is an actuated rotational valve. Another example of the actuated rotational valve is the plug valve that has a cylindrical shape instead of the spherical ball shape. Now let's look at the earliest valve known to man. You can find it in a water pump like this. These valves were used as early as 300 BC together with Roman aqueducts. These valves are a mechanical rotational valve known as a check valve. A check valve looks like a lid on a hinge that'll be in the open position if fluid is flowing from the input to the output. But if pressure reverses and the liquid flows from the output to the input, then the lid will cover the passage, preventing backflow. The lid rotates on an axis, making it rotational. You need this in a pump to get the water into the upper chamber but prevent it from falling back down. With the second crank of the pump, the new water coming up will force the water trapped in the upper chamber out. Check valves are also really useful in chemical plants. Say you have a liquid flowing out of a really hot furnace. The liquid itself is not flammable, but it's flowing to a container with some really flammable stuff. It would be a mega disaster to let that flammable liquid flow back into the furnace where it could absolutely kaboom. A check valve allows the liquid to flow forward, but prevent an accidental backward surge in the next container from causing a big explosion. Your washing machine uses a linear solenoid valve to move a plunger against a spring. The valve can be spring-loaded open or shut, with the plunger moving against the spring to control the flow. You can also find other solenoid valves in dishwashers, automated farm irrigation systems, highly delicate chemical, industrial, and research applications, and the triggers of paintball guns to regulate the flow of CO2 that fires your paintball. It makes sure it fires it with enough force for the paintball to travel through the air, but not so much force that you could injure other players. Another type of actuated linear valve is the diaphragm valve. In this valve, an elastic diaphragm sits above a weir, which is essentially a little hill in the pipe. An operating mechanism pushes the diaphragm against the weir, closing the valve. The stretchy material of the diaphragm smooths hard edges that might erode away in really chemically liquids, and squishing the diaphragm on the weir can create an airtight seal. Lastly, we need to see some examples of mechanical linear valves. In chemical plants, accidental reactions can cause the pipe pressure to skyrocket at any second. Without some way to release some of the pressure from the pipe, you could have a pipe burst and a huge leak, which could be dangerous to the people working there and the environment. The most common type is the pressure relief valve. Here, a plunger is spring-loaded shut, covering a hole leading to extra empty piping, or a flare that will burn off any extra gas with fire. If the pressure becomes high enough to overcome the force of the spring, pushing it to an open position, some of the fluid will be able to escape, relieving the pressure. Now that you know all about valves, look for them in your life. How many valves are in your room right now? How many valves are there in the world? What brand new applications will valves be used for in the future? Go find out!